Okay, this learning target says I can find definite integrals using U substitution. So this time, when we undo the chain rule, we're looking for definite integrals. We actually have an A and a B. So we start this exactly the same way by identifying our inside function. As I look at this given problem though, I'm going to make a change because I would rather use an exponent than a square root symbol. So I'm going to rewrite it as the integral from 0 to 4 of the quantity 2x plus 1 to the 1/2 dx. Now I can see that my u, my inside function, should be 2x plus 1. Just like I did previously, I need to take the derivative of my u, so du equals 2 dx, and I solve for dx, dividing by 2 on both sides. Du over 2 equals dx. So I have the u that I can substitute for 2x plus 1, and I have du that I can substitute for dx, but I also have an interval this time. I have an a and a b, so I have an extra step. I need to find a and find b for u. So if u equals 2x plus 1, then u evaluated at 0 equals 2 times 0 plus 1, which would equal 1, and u evaluated at 4 equals 2 times 4 plus 1, which equals 9. So my integral is actually going to be the integral from 1 to 9 of u to the 1/2 du over 2. Now I am going to rewrite this. Du over 2 is the same as 1/2 times, so I'm going to rewrite this as the integral from 1 to 9, 1/2 times u to the 1/2 du. Now I'm going to do my integration like normal, taking my antiderivative. The exponent of 1/2 plus 1 is 3/2, so u to the 3/2, and 1/2 divided by 3/2 is 1/3. So I have 1/3 u to the 3/2, but I need a definite integral, so I can evaluate that from 1 to 9. I do not have to substitute 2x plus 1 back in. I'm going to evaluate using the u values. So fundamental theorem of calculus, cap f of b, 1/3, 9 to the 3/2, minus cap f of a, 1/3 times 1 to the 3/2. And I know that 9 to the 3/2 is 27, and 1/3 of 27, 1 to the 3/2 is 1, so I have 1/3 27, which is 9. 9 minus 1/3 is 8, and 2/3, or 26 over 3. Now, we're going to do one more. Okay, here's our second one. With our second one, I see that I have a negative sign here in front, and I have a block or an inside function that's in the denominator. So I'm going to let my u equal 2x squared plus 1. Therefore, my du equals 4x dx. I'm going to divide both sides by 4x. Du over 4x equals dx. But one more time, I have to evaluate my a and b. So u evaluated at -2 equals 2 times -2 squared plus 1 equals 9. And u evaluated at 0 equals 2 times 0 squared plus 1 equals 1. Now I'm going to go ahead and set up my integral using u, using du over 4x, and replacing a and b with 9 and 1. So I have an integral. My a value is 9. My b value is 1. Notice that this time the 9 is larger, but I still use it as my a value because it replaced the -2, which was the a value. Now I have a -4x over u squared, and I have du over 4x. So I can cancel the 4x's, and I'm going to rewrite my integral, getting the u out of the denominator, so I still have an integral because I haven't yet taken an antiderivative. There's my interval. I have a -1 u to the -2. That -1 came from right here, and that's still du. Now I can go ahead and integrate. So when I integrate this, I'm going to add 1 to my exponent, giving me an exponent of -1. And I divide -1 by -1, which is +1. So there's my integration. I'm evaluating. B is 1, A is 9. So I need to do cap F of B. So this is u to the -1. So this is 1 to the -1 minus 9 to the -1. And I'm going to rewrite that because I know that that -1 just means take the reciprocal. So this is actually 1, because 1 is its own reciprocal, minus 1/9, which equals 8 over 9. So I have found the definite integral using u substitution.